Yes, connecting a 12-2 metal-clad cable to a 1/2-inch polyvinyl chloride conduit using a polyvinyl chloride female adapter and a metal-clad connector is possible. To accomplish this, you will need the following materials. Firstly, a 1/2-inch by 1/2-inch polyvinyl chloride female adapter. Secondly, a metal-clad connector suitable for 12-2 metal-clad cable. Thirdly, electrical tape. Here are the steps involved. Step 1. Strip the metal-clad cable. Remove the outer sheath of the metal-clad cable for approximately 10 feet to expose the conductors. Step 2. Connect the conductors to the metal-clad connector. Insert the conductors into the metal-clad connector and tighten the screws to secure them. Step 3. Insert the metal-clad connector into the polyvinyl chloride female adapter. Push the metal-clad connector into the polyvinyl chloride female adapter until it locks into place. Step 4. Secure the metal-clad cable. Wrap electrical tape around the point where the metal-clad sheath enters the polyvinyl chloride female adapter to provide additional support. Now let's consider some important factors. Firstly, the metal-clad cable must be properly supported every 4 feet according to the National Electrical Code. This support prevents strain on the connections and ensures the cable remains securely in place. Secondly, the exposed conductor should be protected from moisture and physical damage. Consider using heat shrink tubing or other appropriate insulation to safeguard the conductors. Thirdly, the metal box at the other end of the metal-clad cable run must be properly grounded. This grounding is crucial for electrical safety and helps prevent shocks or electrical hazards. Grounding ensures a low impedance path for fault currents, allowing protective devices like circuit breakers to trip and clear the fault. Now let's delve deeper into each of these steps and considerations, providing more context and technical details. When stripping the metal-clad cable, use a cable ripper tool designed for this purpose. This tool helps prevent damage to the conductors inside. Score the metal sheath carefully and then flex the cable to break it open. Be sure to remove any sharp edges or burrs from the cut sheath to prevent injury or damage to the conductors. When connecting the conductors to the metal-clad connector, ensure that the screws are tightened securely. A loose connection can create resistance, leading to heat buildup and potentially a fire hazard. Use a torque screwdriver to tighten the screws to the manufacturer's specified torque rating. This ensures a consistent and reliable connection. When inserting the metal-clad connector into the polyvinyl chloride female adapter, make sure it is a snug fit. If the connector is loose, it may not provide adequate support for the cable and could allow moisture to enter the conduit. Use a suitable sealant or lubricant to help ease the connector into the adapter if necessary. When securing the metal-clad cable with electrical tape, use high-quality electrical tape that is resistant to moisture and temperature extremes. Overlap the tape layers to create a secure and waterproof seal. Extend the tape a few inches onto the metal-clad sheath in the polyvinyl chloride female adapter to provide maximum support and protection. Regarding the support requirements for metal-clad cable, refer to the National Electrical Code Section 330.30 for specific requirements. The code specifies the maximum intervals at which metal-clad cable must be supported. These supports can be achieved using cable ties, straps, or other approved methods. The goal is to prevent the cable from sagging or becoming damaged over time. When protecting the exposed conductors, consider using heat shrink tubing or liquid-tight connectors. Heat shrink tubing provides a durable and waterproof seal around the conductors. Liquid-tight connectors provide a secure and watertight connection between the metal-clad cable and the polyvinyl chloride conduit. Select connectors that are rated for wet locations if the installation is exposed to moisture. Regarding grounding the metal box, ensure that the box is properly bonded to the grounding electrode system. This can be achieved by connecting a grounding conductor from the box to a grounding bar in the electrical panel or to a nearby grounding electrode. Use a grounding screw or lug that is specifically designed for grounding purposes. The grounding conductor should be sized according to the National Electrical Code Table 250.122 based on the size of the circuit conductors. Now let's discuss some additional safety precautions. Before working on any electrical circuits, always turn off the power at the circuit breaker. Use a voltage tester to verify that the power is off before touching any wires or components. Wear appropriate personal protective equipment, such as safety glasses and gloves, to protect yourself from electrical hazards. If you are not comfortable working with electricity, it is always best to hire a qualified electrician to perform the work. Electrical work can be dangerous, and it is important to take all necessary precautions to ensure your safety. In addition to the above considerations, it is also important to ensure that the polyvinyl chloride conduit is properly installed and supported. The conduit should be securely fastened to the wall or other structure using appropriate clamps or supports. The conduit should also be installed in accordance with the National Electrical Code and local building codes. The National Electrical Code provides detailed requirements for the installation of polyvinyl chloride conduit, including minimum burial depths, support spacing, and bending radii. Be sure to consult the National Electrical Code for specific requirements in your area. Finally, it is important to inspect the completed installation to ensure that it is safe and compliant with all applicable codes and standards. Check all connections to ensure that they are tight and secure. Verify that all grounding conductors are properly connected. Test the circuit to ensure that it is working properly. If you find any problems, correct them immediately. Now, let's talk about some common mistakes to avoid when connecting metal-clad cable to polyvinyl chloride conduit. Firstly, using the wrong size connector. Make sure that the metal-clad connector is the correct size for the metal-clad cable. Using a connector that is too small or too large can result in a loose or insecure connection. Secondly, over-tightening the screws in the metal-clad connector. Over-tightening the screws can damage the conductors or the connector. Tighten the screws to the manufacturer's specified torque rating. Thirdly, not properly supporting the metal-clad cable. As mentioned earlier, metal-clad cable must be properly supported every 4 feet. Failure to support the cable can result in strain on the connections and damage to the cable. Fourthly, not protecting the exposed conductors. The exposed conductors should be protected from moisture and physical damage. Use heat shrink tubing or liquid-tight connectors to protect the conductors. Fifthly, not properly grounding the metal box. The metal box must be properly grounded to ensure electrical safety. Connect a grounding conductor from the box to a grounding bar in the electrical panel or to a nearby grounding electrode. In conclusion, connecting metal-clad cable to polyvinyl chloride conduit is a relatively simple process, but it is important to follow all necessary precautions to ensure a safe and effective installation. By following the steps and considerations outlined above, you can successfully connect metal-clad cable to polyvinyl chloride conduit and ensure that your electrical system is safe and reliable. Remember to always consult the National Electrical Code and local building codes for specific requirements in your area. And if you are not comfortable working with electricity, it is always best to hire a qualified electrician to perform the work. Now let's further elaborate on the importance of grounding, specifically focusing on the role of the equipment grounding conductor, often referred to as the EGC. The equipment grounding conductor provides a low impedance path for fault currents to return to the source, typically the electrical panel. This lower impedance path is essential for the rapid operation of overcurrent protective devices, such as circuit breakers or fuses, during a fault condition. Without a properly sized and installed equipment grounding conductor, fault currents may not be high enough to trip the overcurrent protective device, leading to a prolonged fault condition and an increased risk of electrical shock or fire. The size of the equipment grounding conductor is determined by the size of the circuit conductors, as specified in the National Electrical Code Table 250.122. The equipment grounding conductor must be installed in the same raceway or cable as the circuit conductors. In the case of metal-clad cable, the metallic sheath of the cable itself can serve as the equipment grounding conductor, provided that it meets certain requirements outlined in the National Electrical Code. The metal-clad connector used to terminate the cable must be listed for grounding purposes and must provide a reliable electrical connection between the cable sheath and the metal box. In addition to the equipment grounding conductor, it is also important to ensure that the metal box itself is properly bonded to the grounding system. This bonding is typically accomplished by connecting a bonding jumper from the metal box to the equipment grounding conductor. The bonding jumper should be sized according to the National Electrical Code Table 250.102. The purpose of bonding is to ensure that all metal parts of the electrical system are at the same electrical potential. This helps to minimize the risk of electrical shock in the event of a fault condition. Now let's discuss the importance of using listed and labeled equipment. Listed and labeled equipment has been tested and certified by a recognized testing laboratory such as Underwriters Laboratories to meet certain safety standards. Using listed and labeled equipment helps to ensure that the electrical system is safe and reliable. When selecting metal-clad connectors, polyvinyl chloride conduit, and other electrical components, look for the Underwriters Laboratories or other recognized testing laboratory label. This label indicates that the equipment has been tested and certified to meet applicable safety standards. Using unlisted or unlabeled equipment can void the warranty and may not meet the requirements of the National Electrical Code or local building codes. This can increase the risk of electrical shock, fire, or other hazards. In addition to using listed and labeled equipment, it is also important to follow the manufacturer's instructions for installation and use. The manufacturer's instructions provide detailed information on how to properly install and use the equipment. Failure to follow the manufacturer's instructions can void the warranty and may increase the risk of electrical shock, fire, or other hazards. Now, let's discuss the importance of proper wire sizing. The size of the wires used in an electrical circuit must be adequate to carry the anticipated load. Using wires that are too small can result in overheating, voltage drop, and potentially a fire hazard. The National Electrical Code Table 310.15 provides guidelines for determining the ampacity of conductors based on their size, insulation type, and installation conditions. The ampacity of a conductor is the maximum amount of current that it can safely carry without exceeding its temperature rating. When selecting wires for an electrical circuit, it is important to consider the following factors: the anticipated load, the length of the circuit, the ambient temperature, the type of insulation, the insulation conditions. The National Electrical Code requires that conductors be protected against overcurrent by an overcurrent protective device, such as a circuit breaker or fuse. The size of the overcurrent protective device must not exceed the ampacity of the conductor that it protects. Using an overcurrent protective device that is too large can result in damage to the conductor and potentially a fire hazard. Now let's discuss the importance of proper conduit fill. The National Electrical Code limits the number of conductors that can be installed in a conduit. This limit is known as the conduit fill. The purpose of the conduit fill limit is to prevent overheating of the conductors. When conductors are installed in a conduit, they generate heat. If the conduit is too full, the heat cannot dissipate properly, and the conductors can overheat. Overheating can damage the conductors and potentially cause a fire hazard. The National Electrical Code provides tables that specify the maximum number of conductors that can be installed in a conduit based on the size of the conduit and the type of conductor. These tables are found in Chapter 9 of the National Electrical Code. When calculating the conduit fill, it is important to consider the following factors: the size of the conductors, the type of insulation, the type of conduit, the number of conductors. The National Electrical Code also requires that conduits be properly supported. The support requirements vary depending on the size and type of conduit. The purpose of supporting conduits is to prevent them from sagging or becoming damaged. Sagging or damaged conduits can put strain on the conductors and connections and potentially cause a fire hazard.